schemas and instances, and we described what is the architecture of a database system and what are the three different levels of abstraction, like physical level, logical level, and view level. Now we are going to define schemas and instance. Schema is defined at the logical level. Schema is defined at the logical level, and schema is just like types and variables in a programming language. For example, if you are defining a variable, say x as an integer value, you can take different integer values. Likewise, here what should be the structure of your database? What should be the structure means, if you have a student record, then what are the fields you have to include in the student record. For example, student name, student number, roll number, register number, then his Aadhaar number, etc. etc. A number of details has to be there for a student record. For an employee record, some other details should be there. So that is called the schema. That is called the logical schema. Overall logical structure of the database. Overall, that means if you are designing a database, what are the different records you have put there? So that is decided by the logical level schema. For example, compared to suppose that you are building a house, then definitely there is a plan. There is a plan, and depending on the plan, you are going to build the house. And likewise, here, if you are building or if you are designing a database, then schemas should be defined. Schema define the logical structure of the database. What are the tables or what are the different records you have to put in the database, and when you are building that, then there may be some variations and some structures you have to include, some structures you have to delete, etc. etc. is there. And anyway, the blueprint or this is the logical structure of the database, that is called schema. This is example of database consists of information about a set of customers and accounts in a bank and the relationship among them. This is an example of a customer schema. A customer schema is customer name, customer ID, account number, his Aadhaar number, and his mobile number. Okay. Now, the account schema, this is the customer schema, means this is the customer information, and he is going to take an account and also has taken an account. There is an account number, account type like savings bank, then current account, then a fixed deposit, etc. And what is the interest rate? One is the minimum balance he has to keep, and the current account balance. This is a logical schema. And physical schema means overall physical structure of the database. And as I told you in our discussion on architecture of database, this physical level implementation is outside the scope of this logical schema, and it is up to the designers of this physical level to choose what representation they have to choose from among different possibilities. Okay, so that's all about schemas, and now we are going to discuss what you mean by instance. Instance means, suppose that you have a customer schema and you are going to have a new customer, say XYZ a customer, then you are going to include that into your database. Then that is an instance of this schema. That means, suppose that there are 10 customers in your bank, then their names, their customer IDs, their account numbers, their other IDs, and their mobile numbers are kept as a table. Is kept as a table, and each record, or for example, suppose that you have the first account holder is XYZ, and his account number, customer ID, account number, Aadhaar number, and mobile number. All of this forms a record, and that is a record in your table, and that is an instance of the schema. And suppose that you have 10 customers. Then you have 10 instances of the schema. And account schema is also having account number, account type, etc. Here also we are having a number of instances of such type of that schema. That means schemas are actually logical design of the database, and after that you are physically implement that, and once you have an instance of a particular schema, then you are going to add that in the database. That means if you have a particular schema, once you have designed a schema, there is no change for the schema, but you can add instances, can modify the instances. For example, suppose that the name of a particular person change, then you can edit that name and you can change that name. And suppose that mobile number of a particular person changes, you can edit and modify that. That means new instances can be added to the schema, an existing instance can be deleted. That means you can insert as well as delete instances from the schema, and you can modify the contents of. That means insertion, deletion and modification of instances can be done in a schema. Okay, so that's all about schema. Schema means it's a logical level entity. That means how your data should look, how your representation, what is your representation for customer, what is your representation for account, what is your representation for student, what is your representation for teacher, etc., etc. That is defined by schema. Once you have a defined schema, then you can add instances to the schema, and you can delete instances from the schema. You can modify the contents of the schema. That means each record of the schema is called an instance. Okay, so that's all about schemas and instances. Discuss physical data independence. Physical data independence means the ability to modify the physical schema, ability to modify the physical schema without affecting the logical schema. That means, so if you are changing your logical schema, what will happen? You have to change all the programs with regard to the view level. That means there is an interface between the logical level and the physical level, and another interface between your logical level and the view level. That means those who are viewing this data, they are writing this program, and they know only the underlying logical level. That means the end users. That means if you want to know something from the database, then you have to write code for the view level, and the view level programmers, they know only the logical structure of the program. Logical structure, that means logical schema only they know. That means there is an interface between the logical schema and the physical schema, and here physical data independence means if you change the logical structure or logical schema, what will happen? You have to change all the view level programs. So you have to rewrite all the view level programs, and in that case it is not possible to change the logical schema, but you can change the physical level physical schema. Why? For example, if you have designed your program, if you have designed your physical schema to accommodate say 10,000 records of a particular schema, now we can expand to say 100,000 without affecting the logical schema. That means that is called physical data independence. That means the ability to modify the physical schema without affecting the logical schema. That means logical schema you cannot change. Why? All your programs are written above that logical level in the view level, and the view level programmers or view level designers, they know the structure of the logical schema. Once you change the logical schema, what will happen? You have to rewrite the entire code in the view level. So it is not possible. But there is an interface between the logical level and the physical level. And in the physical level, you can change your physical level. That means your representation can be changed. the number of records it can accumulate can change, and data, that means the physical level change or physical level, it is actually physical level independence means you can do a lot of things in the physical level without affecting logical level or view level. That means that is called physical independence or data independence. Analogs to interface and implementation in object-oriented programming systems, application depends on logical schema. Application depends on logical schema. In general, the interfaces between various levels and components should be well defined so that changes in some part do not affect, seriously influence the others. That means here we have designed 3 levels, and you can if you are not going for major changes, then minor changes can be made in the physical level, logical level as well as the view level. But physical data independence means without affecting the logical level you can change the physical level. Okay, that is called physical data independence, and it is one of the most important properties of database management system. Important properties are the redundancy can be avoided, redundancy or duplication can be avoided, and another most important application or advantage of using database management system is data independence. And without affecting the logical level, you can change the physical level structure. Okay, thank you.